So I think that's all the announcements I have, so I will introduce you to TechSpace. Take it away.
Hey guys, my name's Allison. I work here at TechSpace at the front desk. So if you don't know what TechSpace is, you're in it. It's a co-working space here in Ballston. We cater to a lot of tech startups, anywhere from open desk, hot desks to 1 to up to 16-person private offices. So if you or anyone you know is looking to take a next step into a co-working or a private space, let us know. My site manager, Jen, she has her cards up at the front desk. Check us out online. We also have a lot of meetups like the ones with DC Python and Hatch IT here, so let us know. Thank you.
So, thanks everybody for coming. My name is Lauren and I'm the Community Engagement Specialist at Hatch IT. Thank you TechSpace for hosting us tonight, and our main focus as Hatch IT is just to really connect engineers with local tech startups, and so we're really excited that all of you are here tonight. And lastly, I just wanted to give a shout out to 20 Tables. They're the ones that hosted our food tonight, so thank them for bringing the food in. Thank you all for being here tonight.
Hey, and then I'm Peter Ott. I work at Virtru. We are a small data privacy and security company. We, as recently as August, opened up our platform and launched our SDK with interfaces for C++, JavaScript, and Python. I am personally the product manager for the SDKs, and so I'm here to really share that it exists and quite honestly get feedback on, is it good, is it bad? We have a contest running until the end of November with cash prizes. It's free to use right now, free to download at developer.virtru.com. So yeah, I'm here to spread the word, get feedback, and get some use cases so we can really make this big. But thank you very much for having us, and have a great evening.
Fantastic, thank you. Okay, so with that, we will hand it over to our speaker on time and data and all sorts of wonderful things.
Thank you. I'm Srividya Iyer. I am going to be speaking about all the different date and time objects in Python. I do a lot of time series data, network traffic data. Unfortunately, I can't share the data that we work with because that's private network data. But I have some other time series. So I'm not actually going to show you how to do time series modeling. That would be a 3-hour talk. This is primarily just to get you familiar with all the different date and time objects and things that you can use. So before we get started, a couple of date and time concepts that you need to know is the main date and time structure is an ISO 8601 standard, and that's the link. He actually has a nice detail on different formats for that. And the coordinated universal time, which used to be called GMT, which is not actually the same thing, but everybody just UTC/GMT, and I'm not going to go into the details. You can Google it and find out the differences. So that's the standard by which the clocks are regulated. So any time that you have, your local time is offset of the UTC time. The other time that you need to be familiar with is the Unix time or the Epoch, and that starts in January 1st, 1970. So if you have a timestamp that says it's an Epoch time, that's number of seconds, milliseconds from that time. So that's a much nicer reference because you have a reference time of January 1st, 1970, and then anything else is an offset from that. But life doesn't work that well. If everybody did all the standard notations, we wouldn't be here. So you have all kinds of other date and time formats that you'll see in the data, which is why you actually need to convert them into some standard formats. You have to do any kind of analysis. So, Python. So let's get started with the Python standard library, and then I'll talk a little bit about pandas and numpy. How many of you are familiar with pandas or numpy here? Okay. So Python has two main date and time libraries. One is the date time, and one is time. And I'm not a big fan of the naming because it gets really confusing. There's also some other third-party libraries, which we'll get to in a little bit, to handle time zones, but the main ones are datetime and time. So the datetime module, to make it more confusing, actually has 5 different classes they provide. So they provide a date class. So if you just want to deal with dates and you don't care about time, depending on your data, you can use that. Then they have a time class, which just handles time. And they have a datetime, which is a combination of date and time. So if you've ever seen code which says datetime.datetime, that's what it is. It's the datetime is the module and the datetime is the class. And then you have the time delta, which is the duration, to do a difference of 2 different timestamps. And then you have the time zone info, but that's actually not implemented right here. It's just an abstract base class. So they recommend using dateutil, which is a third-party package. But if you install pandas, I saw that it automatically installs it. You don't have to before Python 3.6, they recommended using PyTZ, and now they recommend you use the dateutil. The dateutil has other things other than just the time zone. It has a parser and various other things which I'm not going to go into, just the time zone. Then you have the time module. So there's the date time module and the time module itself. And the time module typically is used for your Unix timestamps. The other one, the datetime .time, is more object-oriented, and it actually provides a more human-readable option. This one's typically just to do purchase time. Though it doesn't work very well in Windows environment. One of the uses for the time module is to find how long your process is taking to run. But if I run it in the Windows environment, it just gives me the clock time. But in a Linux environment, it will actually get the process time. So the date time, you can create a datetime object and datetime.date object by just saying today's date. So if you want to see instantiated to today's date, you can just have a today method, and then it instantiates it to today's date. It's already instantiated. You can also specify, this is the second way of creating that object. You can actually specify a specific year, month, or day. You can also specify hour, minutes, and seconds, but not in the date object. If you can do it in the datetime object. So the date object is just year, month, and day. So now the time object, same thing. You can create the current time. Let's actually run this. No, it doesn't. So you can do the same thing. There's actually a now method, I think, that you can create to do the current time. So this is a datetime time object. And now the datetime, yeah, I'll give it here, I forgot to do it here. So now the datetime now actually prints the current time.
Is the password?
Is it window plus?
Together.
Sorry, I don't. Just some window.
Thank you.
So, do you see the time here? 1 hour behind. Why do you think that is? Because there are two types of date time object. There is an aware object and a naive object. A lot of this that we have created does not have time zone information.
Could you repeat the two objects?
Naive and aware. So the naive object is time zone and daylight savings time. It doesn't know the time zones or the daylight savings time. And the aware object actually knows the time zone and the daylight savings time. So this one was a naive object, so it basically just created a local time. But now we are in daylight savings time, so it doesn't know that. And it just created it. So it's showing 5:15. So you can find out whether it's an aware or a naive object by doing the time zone info. So it came back as none, which means it doesn't know the time zone. It just prints the local time from your machine, so whatever the local time is. Actually, my computer
if it was aware, it would say something. It would say,
yeah, it would say what the time zone is. If we set the time zone, and I'll show you how to set the time zone later on, it wouldn't show none.
So naive is none.
Naive is none, yes. So the nice thing about having a datetime object, see, remember if most of the dates that you have in files are string formatted. So if you have to get information from a string, you have to do string slicing. And you have to say, give me the year from this, and date from this, and date from this. The nice thing about having an object is it has all these attributes that you can just say, give me all the year, month, day, hour, minute, up to microsecond. So that's the precision of the datetime object is up to microsecond, and we'll look at some of the numpy pandas objects that have much more precision if you're dealing with time data that you need more precision. So the next thing you do with a datetime object is converting the datetime to human readable strings. So when you create the date and time, it just puts it in an ISO kind of string. It isn't quite the ISO format, it's ISO-like string. So if you want it in a specific string format for display, then you need to use string ftime, and there's a whole list of codes that are on the documentation you can look at. I'm just showing a couple of examples here. So it'll format it whatever way you want it. And this is primarily just for display. What I use it for is that I'm writing it out to a file that somebody has to read, then I just nicely format it so it's not like a regular datetime object. So this is the reverse of it. It's called strip time, where you can convert the strings to a datetime object. The catch here is you actually have to say what the positioning of the strings is. It's not going to just know if you just provide a string and say convert it into a datetime. Pandas does that, but this one doesn't. So you actually have to say the first is a year, month, date, hour, and minute. So that's the not so nice part of it, because you can't just give it a string.
I have a question. So are you converting the date time to a numeric format at that point? Or is that?
Oh, here it's converting to a string. And in here it's converting, this is just a string. It's converting the string to a date time. So if I do a type date time, it would be a date time class. So that's a date time. So the next object here that it creates is a time delta object. And what the time delta object does is it provides you a lot of the mathematical operators. So you can say this datetime object and this datetime object, give me the difference between the two, or add the two, or compare the two if it's equal. There's a whole list of operators. I'm just showing a sample here where I'm saying I want to calculate the difference 3 weeks and 2 days before October 1st and 3 weeks and 2 days after October 1st. So this is my October date, which is my October 1st date, and this is my time delta object. So I'm saying that's 3 weeks. So you can provide it in a nice English syntax and say I wanted 3 weeks and 2 days. So it creates a time delta object. So now I can say October, before October is my October date minus 3 weeks, and my after October date is October date plus 3 weeks. So it nicely prints, I mean, it's just printing it. So 3 weeks and 2 days before October 1st is September 8th, and after is October. So this is really convenient if you are trying to do, for me, what I usually use it for is if I'm trying to figure out how many days I want to like match my network traffic for. So I'll create a time delta object and then pass a time delta object and say, give me the traffic for this day. So you can do it for the sales volume and things like that. So that's really convenient to have the delta object. Now we come to our time module. So this is the Unix, primarily for Unix timestamp. So it does a floating number representation time since the epoch. So you can do the GM time, which does the actual Eastern Standard Time. So let's run this and see what it shows. Because I set my time, if you see my computer time, it's 1 hour behind. So it's assuming that the time stamp there is I was just playing around with it. So if I set it back to the Eastern Standard Time, then it will pick up. This is the local time is Eastern Daylight Time. So it's 7 a.m. in the Eastern Standard Time. It basically takes whatever timestamp your computer has and does it. It's not that. Okay, so this is another thing that you will be doing a lot when you are dealing with time. Anything to do with date and time is converting from different formats, because a lot of times you get files. One file will have a Unix timestamp, one file will have a timestamp that's a UTC timestamp, one file will have a local timestamp. So a lot of times you have to convert timestamps from one method to one format to another format, so you can compare apples to apples and not have to deal with different timestamps. So one of the things you can do is you can say UTC, convert the local date time to UTC. So let's see what the UTC time is, which is 11:01, 11 o'clock. At least 4 or 5. Well, my clock is, I think, 5. And then the local date time, you can convert to the ISO format. If you look at back here, it may look like this one is when it prints, this may look like a string, but it's not. It's actually a datetime object. So if you need a string, you actually have to convert it explicitly to an ISO format. So if you do this, now this is the ISO format. So that will say the T actually is required in an ISO format that says, tells the machine that I have a timestamp as well as a date. And that's a string format. And then you can create from your Unix timestamp to a local time, and you can create from your Unix timestamp to a UTC timestamp. Remember the time module, not the datetime time, is a Unix epoch time. So from there, you're actually converting it to more string and object type formats. Most of the Unix timestamp, a lot of the network traffic data gets Unix timestamps. I'm not sure any other type of data gets it or not. Maybe a lot of device logs and things like that also has Unix timestamps. But a lot of the business type files, I don't think deal with Unix timestamps at all, but probably others. Okay, now the fun part.
For the UTC from timestamp, how does it know what your current time zone is?
It just checks whatever the time zone I have set on my machine and picks it up. So I changed my time zone on my machine, so which is why it's, if you look back here, it's showing central time and not Eastern time.
Whatever your operating system has?
Yeah.
Yeah.
And each operating system varies on how it timestamps and how much, that's a whole different ballgame on how, whether it does the TTP precision or the NTP, or you're just setting local time, or you're connecting to an NTP server and all that. So a lot of times when we collect data, you have to make sure all the devices are synchronized properly. Otherwise everything is a different. This is a headache we have to do, but collection is a whole different headache. Now the fun part. So till now we were dealing with naive objects. We didn't deal with any timestamps. It just basically took whatever was on my machine and said, okay, this is what you have. So now this is how I want to set it. So let's say I'm dealing with traffic. One of the things we deal with is you might be collecting data from a data center in Kansas City and a data center in San Diego. And a lot of times it comes stamped with, if it comes with Unix time, we're good because it's a reference. But a lot of times it comes stamped with local time. But 3 o'clock in Kansas City, the traffic is not the same as 3 o'clock in, so I can't match. So I have to make sure that I have to reference it to a certain time zone or convert it to a UTC time zone. So this is what helps is you set it to a particular time zone and reference all your data to that particular time. So here I'm just defining if you want to know where you get this string from, it's called the IANA or an Olsen database, and that has a whole list of strings defined for like English human readable strings for different time zones that are unique. So before there was an older database that would say mountain time, but there are several mountain times, especially when you're traveling in Arizona or New Mexico. The Navajo and the Hopi don't change their time zones, but Arizona, they change their time zones, and Arizona doesn't change their time zone. And you're like driving between, and your phone is constantly updated. And so before they would just say mountain, and you didn't know exactly what all the mountain times were. So this one, it'll say Navajo, it'll say Arizona, it'll say something else. So it has like a string of representation of time. So that's the Olsen database, and that's why they now recommend that you use the date-util time zone instead of the older ITC. Any questions before we go into numpy and pandas and how they handle time? So this is just the Python standard library, the datetime and the time modules, and the date tutor, like I said, is a third-party library, but if you install pandas, it seems to install it because they use the date util to handle time zones as well. So I think automatically it's a dependency. So let's move on to so now numpy has its own datetime object. And they called it datetime 64 because datetime is already taken by the Python standard library. And to make our lives harder and more confusing, they called it datetime 64. I'll go through the differences between all these different time objects. So the nice thing with the NumPy datetime object is you can actually do a lot of the NumPy operations on it, like array manipulation, or let's say you have an array of time strings, you can use NumPy to do that. It's kind of hard to do that in your datetime object. I would have to create a list of dates and date times and then manipulate the list, and list gets kind of a pretty expensive operation to manipulate lists. So if you're dealing with a lot of just arrays, it's better to use the NumPy's datetime object. NumPy doesn't have a date and time separate. It just has a date time and a time delta. Unlike the Python standard library, which has date time, and time delta, this is date time and the time delta. And they call it date time 64 and time delta 64. Of course, the way you actually create it is slightly different. You can just say, if you just want like a nanosecond precision, you can just say an integer and whatever precision you want. It actually goes up to 10 to the power of 18, which I have never had any need for. This is my limit, is the nanosecond precision. But that's one of the, I think if you do like astronomy or astrophysics or something, I think you may need 10 to the power of 18, but most data you don't need it. So this one, when you give it an integer and the nanosecond precision, it just does your Unix epoch. You can also just create it using an ISO. This is the one difference between the NumPy and your datetime and the pandas, is NumPy expects an ISO 8601 format. You can't just provide it some random string and expect it to know. So it has to be an ISO format. And the time delta is also slightly different. So you can say just the formatting and the code is slightly different for doing time delta. So this is how you're specific, but it's a single unit. You can't do what we did, remember, in a Python standard library where you can say 3 days and 2 weeks more English. Here you have to just provide one unit, whether it's days or hours. That's because NumPy is primarily used for like array manipulation, so they are not really looking to provide a lot of user-friendly things. It's more for like performance calculations. This is the nice.
Can you combine those time deltas then, like days and hours, to get that type of effect?
As like an addition of time deltas, yeah, you could do like, yeah, you can say this time delta plus this. It provides mathematical operations if you want, but it gets clunky to do that. If you're really just doing the time delta, it's better to use the date time in Python. So this is, you can also do this. You can create a time delta by adding or subtracting like two NumPy datetime objects, which is one way to do it, which will give you like a precision base in milliseconds here. You can, that's the default because I didn't actually specify what kind of precision I want, but I can do whatever precision I want, and I can say I want to subtract the two, and then I get the actual delta, which is the interval. So numpy, that way it's, it just has the two objects, and you basically create the object and you do. One of the nice things is you can actually do, like I said, you can do a lot of the numpy array manipulations. So if you go to the numpy documentation, they have a whole list of array manipulation things that you can do with a data object. So pandas actually has two objects as well. Pandas is a timestamp, which is pretty similar to your Python standard library datetime object. It just has more functionality. So they are interchangeable. If you don't want to deal with, remember, they all come with overhead, nothing's free. So if you don't want to actually deal with pandas and the indexing and all that, and you just have a simple file that you just want to do dates and date deltas, you're fine using the datetime library. There's no need to use the pandas. So they all have sort of their purpose, and why you want to use one over the other really depends on the application and the data that you're dealing with. So the timestamp is, like I said, very similar to the Python datetime, but it's more functionality. And there's two ways to create them. You can either create the PD timestamp or the PD to date time. So this one defaults to nanoseconds as well, because they are using underlying, if you look at the code, they're basically using the numpy datetime 64 object. So they've kind of built it on top of that. It's just more user-friendly than the numpy, but it comes with some performance loss. If you just want to do basic calculation, you can use numpy, but if you want a little more readability and easy coding, then you can use the pandas. Again, it's slightly different format. See, like you can provide partial strings, and they don't have to be ISO format. They can be any strings, and they still take. So that's all the advantages of using the pandas timestamp. So I'm creating the pandas timestamp using a date time. So if you see, this is a timestamp object, which is similar to your datetime object. This is one advantage of having the pandas is you can create a list of strings into a data frame of timestamps. And then you can say, and I'll show you guys an example with a file. So then you can say, I want my date as my index, and then you can do index manipulation just like you do with any other file. So this functionality is not available in the datetime in Python or NumPy, because NumPy doesn't do explicit indexing. NumPy does intrinsic indexing, so you can't actually set the time as the index and do index manipulation. So that's the one thing, if you really need to do that, then you need to do this. So this is a little example I had. So this is my date field, the sale date. And this is like house sales in Sacramento. What I really want to show here is if you look at the sale date, this is an object. So an object in a pandas data frame could be anything. In this case, it's just a string. So if I have to do anything with it, I have to do the whole string song and dance to get the year and date and all that. So Normally, when you have this and when you need to deal with any kind of date related, you want to set it to a data type of cell data to a data type of data. So I'm basically converting the cell date from a string object to a datetime object. And now if I look at it, if this is a datetime 64 object. In the system, it's a nanosecond precision because I wasn't giving it any kind of precision. So that's the default precision. I left the error message in here because going forward, they're forcing all the objects to be aware objects and not naive objects. So what it's saying is right now it's okay, but if you don't pass in the time zone info from the next version on, it's going to be an exception. From now, it's a warning. So they're forcing it to be only aware, always know the time zone information. They use the date util time zone, so it's easy enough to pass. So now I can get information like what is the day, what are the days, it's the day 21st is the days. I can say what was the hour, the most hour, or the most dates that had a sale in it, or any kind of manipulation on the data. So this is the last thing. I just want to kind of summarize the differences. And like I already said, why we use all these different datetime objects really depends on what you're trying to do. NumPy doesn't have a separate date and time. The datetime modules is a microsecond precision. So if you want anything more precise, like a nanosecond, you're automatically forced to use either NumPy or pandas. Like I said, it provides 10 to the power of 18. This one I'm not going to go into detail, but since we have all like 3 different varieties of datetime objects, you can actually convert one from another. And a lot of times you have to, because part of it you're reading using a regular CSV, and then you're trying to convert it into a pandas data frame. So it's pretty easy to convert from one datetime format to another format. So at least, even though there's 3 different types of datetime formats, at least they're seamlessly allowed to be able to convert from one to another. So I'm not going to go into detail. You guys can look through this just on different ways. That's all I have, I think. Any questions? I know this is not the most, it's kind of down in the weeds kind of stuff. But any other questions? Okay, yeah.
So, are we going to get these?
Yes, I actually posted it on the comment for the meetup. So it's on my GitHub and you can download the.
Yeah, we'll just send it out afterwards. Send out the videos, but do the live streaming, so we'll send out the recording, and we'll send out like this again. Just make sure everyone has it.
So pandas as type, if I understand, how does that work? I didn't see that.
Oh, I didn't put all the variations. Yes, you could do as type. Yeah, you can set it to. The reason I did it separately was just to show you when you read it, you can just say D type is date time. It'll automatically read it in as a date time. So you don't need to.
So I guess I was mostly curious about how many different. That's what I'm used to with the as type.
Yeah, and that's your setting.
Very simple.
Yes, because you're setting the type later on, just like how I did it. So.
But it seems to interpret lots of different strings as properly. Like I've used different formats and I never realized what format they were in. Your various data came from wherever.
Yeah.
But that as type seems to recognize quite a bit.
Yes, it does in pandas. That's what I mean. Pandas combines the ease of use of the Python datetime with the numpy's, not quite numpy's performance, but most of numpy's performance and precision. So yeah, the AST type will recognize the datetime. But I usually like to set it explicitly rather than,
this was the question I was trying to grab at was what was the penalty for the pandas as typing so easy?
Because then it goes through, if you look at the code in the back, because it's dynamic typing, it tries to infer so that there is a performance penalty. If you run like the cabinet, you'll see. It's no big deal for these 10-line files, but if you're working with millions of rows, yes, then this. Yes.
You said you work with network research.
Traffic data, yeah.
Network traffic data. How do you integrate all this time-dependent data with your network? Are you using something like a graph database?
There's time series database that we use that collects the data and timestamps it and keeps it, and then we read it in and use Python pandas to read it in and do that.
And that gets combined with like some kind of like a graph database or something?
No, it's just time series data. There's no graphing, as in like this is just traffic.
Yeah.
Point-to-point traffic, not your whole.
Okay, your whole network.
Yeah.
Okay.
So I'm currently working on PySpark and a lot of distributed data. Which one is more scalable?
May I repeat the question?
Yeah, I didn't hear it. So PySpark.
Oh, sorry.
Well, both of you.
Yeah, actually, I only heard part of the question.
So for example, like I'm using a lot of PySpark and for we have a cluster.
Yeah.
So we're having issues with some of the libraries being not very scalable.
Mm-hmm.
Which one is the most scalable?
Depends on, it could be either pandas or numpy, depending on if you are just doing like array manipulation and you don't really need any of the other things that pandas provides, like like setting different things, but just doing, then I would use numpy. But if you need things like changing the format of this and changing the format of that, then pandas would be better.
Okay. So I work with Apache Arrow, right?
Yes.
Okay.
Go ahead. Yes, sir.
When you converted the sales date to a date time numpy object, is it already formatted for you, or that's strange?
It was created as a datetime object, and then I can use that to do all the datetime related methods. Any kind of datetime related functions. Yes, it's already been converted to it.
I mean, for you to input it, the string is already formatted, the sales date. It was already, because I remember you said it had to be in like ISO format.
No. You still have to format. It's a date time or timestamp object. If you wanted more user readable in whatever, say, Wednesday, October, or today's Tuesday, October 22nd, then you still have to do formatting, string to be able to display it in like user readable format. You should have. Yeah, it doesn't. If you just print it as is, it'll print it in whatever format it's in. So that'll be the timestamp format is left here. So this, if you just print this as is, this would just print like this. But if you wanted like an English, say October 22nd, the format I was showing, that still needs to be string format.
Okay, if there's no other questions, we'll call it a night.